Well, good morning. It is coding game time. Quick recap. This is day 8 of the challenge. I've wasted most of it trying to implement a Monte Carlo tree search algorithm in JavaScript. Should have known it wasn't going to happen. Well, I did manage to make the algorithm. It works technically. That's what I've got living in the arena right now. I'm in the Bronze League. But JavaScript being so slow and this particular challenge being pretty complex and having like a large branching factor, um, I'm not able to get enough simulations out of my Monte Carlo tree search algorithm, so it's barely better than just random. Uh, like it's smart enough to not do stupid moves that would get it into trouble, like, you know, getting locked or something like that. But other than that, it's not great. So I threw the towel in yesterday and decided to go for something simple at first, just a breadth first search algorithm, which I've implemented. And of course, again, it's a pretty large branching thing, so that's not going to work. Let's take a look at what happens. The algorithm works, but given that we only have 50 milliseconds, um, it times out. So the first turn was fine because we have more time on the first turn. And at the moment, I've got it I coded it. The way I coded it, it's actually looking for the for all those 5 client orders in the tree. So it's looking at all the possible moves, and once the inventory is enough to brew one of these potions, it flags it as, all right, we found a solution for that. And then I can get the path by just backtracking and going through recursively the nodes all the way up to the parent. Um, and the idea is that I create the graph at the same time as I'm looking for that. And I'm looking for all 5. That's the way I've got it set up. So technically, if I had enough time, the graph would, the search would go its breadth for, so every turn until it finds the solution for all of those, and it would be the quickest solution, the quickest way to get to all of those. My idea at first when I implemented that is, all right, let's get the amount of steps, the minimal amount of steps necessary for each of those, and then take their price and divide it by that amount of steps, which will give us like the um, the order to that's the most um, I guess worthwhile, right? Like the one I get paid most per turn to try to get to. But the algorithm is not fast enough for that. There's branching factors too big, and if I think like if it's in the neighborhood of 8 to 10 turns, it's fine. I'm able to expand the tree to about 8 to 10 turns. But when you get over that, it quickly, like it's exponential, right? Breadth first search. So um, I quickly get into trouble. So there are some games where it just happens the mix is just right. I can get a little further, but most games I'll just crash on the first or second turn. But I've tested it and it's sound. Like the algorithm it works. So the thing I did just to alleviate the problem here is instead of looking for all 4, um, I basically said, all right, you know what? Targets is our client orders here. So there's 5 at any given time. So I said, you know what? Once you've found one, you can stop. Just like find the one I can get to quickest and then stop. And even then, as you can see, even then it crashed, which means that like the it's too much. Like 10 turns is too much for 50 milliseconds. It works on the first turn where we have a second, but after that it crashes. Let's try another one. Maybe we'll get lucky and the quickest one we can get to is like 7 or 8 turns. Oh, there you go, 6 turns. And I'm able to get further. And okay, so look at what happens here. So you can tell the algorithm's sound, right? Look at, let's see. So this is the first turn. Okay, it went through 164 nodes, which is a peanut, right? And it's saying, all right, we're going for order 46. Order 46 is this one. Right, so it's 3 blues, no, 2 blues, 3 green, which I've got here as well, in 6 turns. All right, so let's step through that. That's the first turn, is it? Why didn't it change? Oh yeah, it displays the first. Okay, cool. Then it's saying 5 turns. Still going for 46 and 5 turns. And you can tell like the amount of nodes it needs to go through diminishes every time. So that's right, 3 turns, 2 turns. Meanwhile, it's doing what it needs to do, right, to get there. We're resting at the moment. 1 turn, casting 79, the final piece of the puzzle. All right, and 0 turns. So we will brew order 46 in 0 turns, right? We are brewing it right now. 1 node to go through, which was the parent node. And we brew, cool. We get our 11 points, nice. But now, and here's the problem. Yeah, that's a very good point. Why don't I just kill the algo if it takes too much time? For sure, that's on the list of things to do. As you can see, I've got make it anytime, right? So I have yet to do that. I've got a few ideas I want to explore first, but yeah, definitely. Like just some sort of stupid thing where, you know, if you're getting short on time, just stop and give me the best result you've found so far. Or if you haven't found anything, just pick a move at random, I guess, out of the ones you can do that are legal. Something like that. For sure, I'll be doing. Um, but there are things I want to tackle first that I'm going to have to tackle anyway. So, which mainly is pruning. Let's see. Let's take a look at this quickly. So this is when I was still going for the Monte Carlo tree search thing. I have yet to implement the bronze rules, by the way. That's what I implement learning. It's not like machine learning or anything like that. It's the spell learning. Okay, so save graph and reuse. I'm not doing that right now. I'm just starting from a fresh graph every turn, which obviously is not optimal, right? I'm going to get to that. Cut search when running out of time. Oh, right, which is basically the same thing as make it anytime, but so I've yet to do that. Prune according to heuristic. That's what I'm working on right now. We'll get to that. Implement backtracking. We'll see if it makes sense. Maybe. Yeah, okay, so here's what happens. Once I'm good, great, I brewed something real quick, and it happened to be like the one with the best bonus. But now what happens is like, oh, cool, empty inventory, right? Starting with no ingredients. And now I'm asking it to search, you know, how can I get to these? And look at these. Like they're all tier 3, tier 3, tier 2, tier 3. All right, so they're gonna take more, and starting from no inventory, they're gonna take way more than just like 6 or 7 turns, and that is why, baff, it crashes, because we get into crazy territory in terms of, so 6 turns is 164 nodes that I'm going through, and it's exponential. So presumably, like at 7, 8, 9, 10 plus turns, we're in the tens of thousands of nodes, probably, if not more, that I'm creating, right? Because I didn't create the graph ahead of time or part of it. I'm just doing it every time. Okay, so let's tackle one at a time, one of these things at a time. So what I'm working on right now is I implemented two little functions. I'm going to use okay, beam search. That's what I'm going for. First time I actually try to do that, beam search, I understand the concept. I've read some research papers on it. It's relatively simple. What you do is the idea is breadth first search just goes through the entire tree, right? One layer at a time. Boom, boom, boom. And then the problem is it gets huge and it's, you know, a problem in terms of how much memory it uses because you're storing the nodes that are yet to be visited. So the next layer is stored in memory. And there's the compute, time of going through all those nodes. Many of them um, won't lead you to most of them actually won't lead you to the answer you're looking for. So the idea with beam search is you're projecting a beam through that, right? You can imagine like a pyramid. Whoop, there we go. So you're starting with your root, and then it goes down like this. Every layer, there's more and more children node, more and more children node in the tree. So what you're saying with the beam search is you're saying, all right, you know what? Let's cut that off. Let's like project a beam through that and just prune whatever's on the outside of that beam. Now, of course, it's not straight down the middle. It might be, there's depending on how you do it. And the way I want to do it is use a heuristic, a simple heuristic to sort. So whenever I'm at a node, um, there's a step where you need to create children node. So here's my game state. I am able to do these three actions. So cast spell 1, cast spell 2, cast spell 3, which will lead me to 3 different states. Cool. So that's 3 different children. Now what I want to do is use a simple heuristic and score the next state. Boop. Score the next state to figure out which one is most likely to get me to the answer I'm looking for. And then basically um, only only on the next layer, only expand the ones that are most likely to. So I guess it's kind of a mix of best first search and breadth first search, beam search. It's kind of guided. And I guess if you go like really like, so you get to set how many like your slices of every layer, you get to set how many modes you want to expand. So if you go extreme and you say I just want one, it ends up being a greedy kind of search, right? You're just saying like only expand the one that looks most promising. So with that same algorithm, you could have just a greedy search. So it's kind of interesting. Okay, so to do that, I need my heuristic function, which I've already coded. Now I'm just testing it to make sure that it's sound. Um, so individual heuristic takes in my inventory and takes in a target. So the potion we're trying to brew, like we're looking at. What I'm doing, like it's not a perfect heuristic function by any means, but it should be sufficient. It should be fast enough, I guess, and sufficient to guide the search a little bit. I'm basically just taking the tier 1 ingredient from my inventory, right? And I'm applying that. I'm adding it to the cost, right, of the target. The target, the delta, right? So I'm getting the delta from the target, and I'm getting just the tier that I'm interested in, tier 0. Oh, look at that. I have screwed that up. So that's interesting. let's change that. Get tier 2, tier 3. Gotta compare same things. And did I not? Okay, that's interesting. It's very useful to use math.min with only only one parameter. Okay, yep, that makes more sense. Okay, so getting tier 0 from my inventory, applying the delta from the action for tier 0. Again, that's tier 0 right here. What's confusing and what confused me, I guess it was the second parameter to math.min, which is 0, because what I'm saying is if we have more than enough, right? If I have, let's say, 3 or 4 tier 0 ingredients in my inventory, and the delta is only 1, all right, then just use 0 as a value here. We're good. There's no cost, right? We have what we need. But if we don't, then we'll get, okay, we're missing 1, -1. We're missing 2, -2, right? And then I multiply that simply by these numbers here for tier 0, 1, for tier 2, 2, or yeah, right, for tier 1, tier 2, for tier 2, 3, etc. And that's kind of just to represent the fact that, you know, usually if you want to get a tier 0 ingredient, it's just a one spell thing. If you want to get a tier 4 ingredient, and you're starting from scratch. So that's why I'm saying it's not perfect. I'm not like actually computing exactly like with my inventory. Do I, oh, you know, can I convert something and taking rest into account? I'm just being really simple. Like if we're starting from scratch and I want to get a tier 3, how many turns is that going to take me? Well, it's going to take me 4 turns, right? I need to create the tier 1, tier 0, convert it to tier 1, convert it to tier 2, convert it to tier 3, boom, 4. So it's not perfect, but it should be enough to guide the search a little bit, is what I'm thinking. So I end up with a cost, if you will. It's a negative number representing the theoretical amount of turns that it would take to get this many amount of each ingredient, each tier ingredient. I just add those up together, which will give me a negative number, either 0 if I have everything I need, or a negative number. The smaller the number, the further away we are to where we're trying to get. That's the idea. Okay, so that's on an individual basis for a particular action. Now, the heuristic I'm planning to use to guide the search will take all targets into account. It's going to look at all of the potions that are, all the orders that are available. And it's basically going to calculate the individual cost for each of them and add that. So we'll end up with a sum, right? Which is kind of like, if we're using that, it's kind of like averaging towards the, you know, kind of the middle of where all of these are. So I expect this could be a problem if it's really spread out. Like if the orders aren't similar at all, I could end, like you could end, if you're looking at a pyramid, let's say, and you know, one order is like way down here and it only needs tier 3 ingredients, right? And the other order is way down there and only needs, I don't know, tier 1 ingredients, right? So this kind of formula would say, you know, would probably say like there's a tension between those two. They're not similar at all, and so it's gonna end up kind of trying to go in the middle. So I don't know. We'll see what happens. Um, it's gonna find a solution eventually, and the thing is, it's not going to be optimal. It's going to be longer more steps than if it was just a pure breadth first search, which guarantees the shortest path. But I'll be able to go through a lot less nodes, get a result within the time constraint. And my thinking now is let's do that. Um, and it's basically turning your depth first search into somewhat of a depth first search, right? You're going deep instead of wide, but not just one deep, right? It's kind of like it's a swath. It's like it's a beam. It's interesting. Anyways, so let's go. Let's do that. Quickly find an answer to our question. It's not going to be the best one for sure. It could be pretty good though, depending on if we tune it right. It could still be pretty close to the optimal number of steps. And if we get there, um, and there's time to spare, and this is where the backtracking part of it comes in, I could store, instead of just discarding the nodes I don't want to explore as I'm doing my beam search, I could store those, the one I didn't expand, the ones I didn't explore. And if there's time to spare, let's go back up and look at those and see if maybe as we expand those, we can find a solution that's even better than the one we have so far. All right, so that's generally the algorithm I'm going for. Something's going to go wrong for sure, as it always does. But let's try. We'll see what happens. So first thing, I just want to make sure before I throw that out in the wild that um, my heuristic is sound. So first test case here, if I have my inventory, this is my inventory here. If my inventory is 1111, and the cost, this whole thing here is an action, is the brew. We don't care about these here, so I just set them to 0. I'm only interested in the delta, the cost. So if the cost to brew is 1 of each, technically, I've got everything I need. The score should be 0, right? Now, here I've got nothing in my inventory. Same cost, -1, -1, -1. All right, so let's figure this out. What would we expect the score to be? So let's see. So we'd expect 1 for tier 1, right? So 1 times 1. Well, actually -1, I guess. Well, let's just do it in positive and flip it later. So we expect -1. We expect 2. We expect 3. We expect 4, right? So we should have 4 plus 7. 4 plus 3 is 7, plus 2, 9, plus 1, 10. And this is what it's saying, right? -10. So I just need to say, yep, I'm expecting -10, and oh, I've got to be 0 because I was, so instead, let's pass in our expected as a parameter. For those of you that are wondering, I'm using Jest as a test framework and this wonderful little tool called wallaby.js. If you're doing any TypeScript, JavaScript development at all, you need to look that up. It's about, I think it's about $100 a year. Well worth it. It's amazing. Like basically life tests, straighten your IDE. You can debug, step through it. It just works wonderfully. Can evaluate stuff too, right in there with like little things like that. All right, doesn't make sense here, but if I was to do, let's say 1 plus 1, and then go, there you go. So it's running 2 tests here, which is why we're saying 2, 2. But it's saying, all right, you asked me to evaluate and print what this is, the result of this line here is. Well, it's 2, and it's 2. You can even get, okay, so this is pretty cool. You can even get like profiling information. Let's see, what's the oh, I think it's something like this. Maybe invert this. I don't often use it, but do I still need? Well, I'm gonna have to look it up. But basically, when you when you do it correctly, it'll print out like how many milliseconds or nanoseconds it takes to evaluate this line. And if it's in the loop, it'll even tell you like on average how much time the worst loop, how much time it took for that line to evaluate. That's really cool. All right, enough of that. And let's add another test case, something a little bit more complex, maybe. Let's say we have in our inventory. No, I don't care. Let's just make it empty. And let's make this a little more complex. Let's change that to 2. Let's change that to 3. Let's make this, I guess, 0. What did I just do? Okay. 0 and -1. Cool. All right, let's figure this out. We would need, that's 2, that's 6, yes. That's 0, and that would be 4. So 12, yep, and that's what it's saying. All right, so, all right, pretty confident this works the way I expect it to. Now let's add one for our what did I call it? Just heuristic, right? The one that takes into account all the targets. That's going to be a little bit more annoying to test. Do I want to trust that since this is basically built on top of this, it should work? Let's just, all right, so I'm taking my targets, reducing them. The total at the beginning is 0. That's what this 0 is here. I'm initializing P to 0. And then for each target, C for current. That's a convention. It's not very clear, but when you're used to it, it's previous and current. So I'm taking the total so far, 0, and I'm adding the result of my individual heuristic. So let's say it's -3. Cool. Next target, C is new. I'm starting with P, which would be -3. I'm adding whatever. Oh, yeah. So that works. All right. Let's not bother with the test. Famous last words. And trust that this should be what we're doing right. Let's reformat that. Good. Good. Okay, so that was the heuristic function. Now, how do I implement this? This is the part of my code that actually, yes, this is where I create my new nodes. And I said I want to sort, right, so the heuristic needs to happen here. Or does it? Well, yeah, the sorting, it makes sense that the sorting would happen here. Or maybe not. So right now I've got one queue and everything ends up in the queue. I don't have a concept of layer right now, right? So at any given time in the queue, I've got, so imagine I'm starting from the root and there's a few layers done. Now I'm starting a new layer. So I've got, the node at the very first node in that layer, right? Boom. So what's left in that, and I evaluate it, and I do a bunch of those, and I'm in the middle now. Well, in that queue, I'm going to have whatever remaining nodes I haven't expended yet that are on that layer, but I'll also have the children node from the next layer that I have already evaluated. So it's all jumbled up together. I guess I would need I'd need two queues. I'd need one queue for the current layer and another queue for the next layer. Does that make sense? Yeah. If I do that though, yeah, it changes a little bit. Yeah, okay, not quite clear how I'm going to do it yet, but let's just dive in. So current queue or current layer queue, current layer queue. Let's do that. There we go. Cool. So that's a lie at the moment because we have nodes from the other. How am I gonna? Okay. Let's just do that. Next layer. Queue. It's probably code samples of this somewhere on the internet, but let's just wing it. All right. So while current layer queue dot length, so while we have stuff in our current layer queue, we keep going. Current layer queue shift, pop node out, then go through our targets to see. So all of this here is basically this loop here is just termination check, right? Did we find, well, not quite, but did we find one of our targets? Basically, is my inventory at this particular state, in this particular state, no data inventory, right? Is it, when I add the delta of the target to my inventory, are they all non-negative? Do I have enough, right? Do I have enough to brew? If yes, I add that target to the found set that I've got here, right? Keep going. Then I look at each of the found sets, each target in the found set. I delete the target from my targets set, basically saying I found it. Don't need to look for it anymore. Look for the other ones. Worry about the other ones. I'm going to need to change that now because it's no longer a pure breadth first search, and I might end up finding a better solution. Well, no, not yet. That would be true if and when I implement backtracking. For the moment, we're going to keep that because we're essentially doing a breadth first search inside of our beam. So whenever I hit the target is within that beam, it's the best we're going to get. So that's fine. Okay. Ideally, it would be changing that to 0 soon, but we'll leave it to 4. Okay, now get valid actions. This is, I'm taking in the spells that I have in that particular state, taking in my inventory, I'm taking in all of the targets, and I'm all the brew actions. And I'm generating valid actions. Why do I need to take... Hey there. Where are you at the moment in the contest? I'm in the Bronze League. Yep. Wasted a lot of time in the past few days trying to do a Monte Carlo tree search algorithm. There's just not enough compute time for JavaScript to do anything that works with that. So yeah, I'm doing the beam search. That's what I'm doing. Unless you meant bean, in which case, no, I'm not looking for beans. It'll be the same for BS. Yeah, I know. I got to do something. We'll see. I have more hope that I'll be able to do some, and I'm not doing the entire game state. Like my Monte Carlo tree search, I was trying to do the whole, like I was taking the opponent into account and his moves, and right now I'm doing a beam search with my stuff. Just like here's my inventory, here's what I'm trying to brew. Just how can I get to that, right? And I don't even have the bronze rules in yet, so I'm not worrying about learning spells. I'm not worrying about the bonuses. Uh, the way my bot is right now in the arena, it's barely better than random. So that'll be an improvement once I've got that set up, and then I can try to build on top of that, depending on how much time I have left. It's always the same thing with these contests. This is my fourth, I think. Every time, man. 11 days is not enough. Every time I like try something and I dive in with these great and grand ideas for some all-encompassing algorithms that'll do everything for me without, having to worry about domain knowledge. And then halfway through, I'm like, crap, it's just not enough time, not enough compute time for it to work. And then I have to rush and revert. OP moves are not really an issue, but yeah, if you need one, you should switch to a language with more compute power for such algos. Yeah. That's what I'm next. And I always, I'm attracted to those. I don't know why. Like pretty much every contest, every game, my mind's always like Monte Carlo tree search, right? Because Monte Carlo tree search is just like, here are the rules. You figure it out, right? Basically, it's like just randomly play out using those rules, see if I win or if I lose, backtrack the result up there, and that's it, right? But you need to do like a crap ton of simulations for that. Expand 11 nodes, and I know even like in the C or C or Rust, even then, not all games, given only like 50 milliseconds, are suited to that. But still. So the next challenge probably will be either C Sharp, which I know already pretty well, and Rust, which I've played with a little bit. Oh, cool. Finished 40 on Code Royale with JavaScript. And yeah, after this achievement, I moved to C++. Yeah. The best I have done is on Ultimate Tic-Tac-Toe. And in JavaScript, with a Monte Carlo tree search algorithm, I ended up ranking, and mind you, that's not in a contest context. I did that afterwards. I wasn't doing CodinGame when it came out, but I think the best my bot ended up ranking is like top gold, and that was one of the first ones I did. So my MCTS implementation is not that great. I'm not using bitboards, for instance, which you know tic-tac-toe is a good it's a good place to do that. So I could probably squeeze out more out of that. But yeah, that's the kind of anything more complex than that and MCTS goes is not. It's hard to use. It's not going to work with just 50 milliseconds. Okay, so um, I guess here instead of pushing in the current layer queue, we now need to push in the next layer queue. Right. Cool. Now, how do I make the switch over? Right? Um, see you in gold or legend. For this contest, doubtful, my friend. Doubtful. I'll be happy if I make it to silver. I'm pretty sure I can do that. Like with the time remaining, I'm pretty sure I can get to silver. Gold, I don't know. It's just the time constraint is legend. Forget it. One day I'll make it to legend, and it would be awesome if I could make it with like just using JavaScript. I would love that. But I need more experience in these contests. That's what's going on. Like I do a lot of stupid things at the beginning. I waste a lot of time. I implement stuff in a certain way and then realize, oh man, it's not going to work that way. And most of the time, it's not because my algorithm is not good or the idea is not good. It's not sound. It's because of the time constraint and all that. And so, give me your nickname. I'll follow you on Twitch, Twitter, CodinGame. CodinGame, I'm guessing. Snowfrog. Snowfrog Dev, Snowfrog, whatever. Let's see. Snowfrog Dev, you've got it right here. All right, so we're pushing to our next. Oh, by the way, oh, this is funny but sad. This is the kind of thing, right? Yesterday, I pushed a little bit to. I scrapped my Monte Carlo tree search, implemented breadth first search, and I was sure everything was right. I'd run it, and there was this weird behavior where, first of all, the algorithm would come up with like a solution that was way longer than it made sense, right? Like, whereas I could just by hand figure out that I could get to this potion in like 7 turns, it'd tell me like 38 is the best I can find. And then when I look at the steps, it was always cast, rest, cast, rest, cast, rest, cast, rest, cast, rest. I'm like, what the heck? I spent seriously at least an hour and a half to 2 hours trying to debug that thing with console log stuff, and to realize that I was using, instead of pushing to my queue, I was using unshift. So if you're not familiar with JavaScript, basically push is the array is kind of it allows you to basically use it as a queue or as a stack, depending on what you're using. So if you're pushing, you're adding at the end, and you're popping, you're removing from the end. So that would be one way of doing a stack. You could do it the other way too. You could shift or unshift, which is adding at the front, and unshift, removing from the front. So either way, if you're using those two, your array is a stack. But I need it to be a queue in this context. But what I was doing is I am shifting here. So where is it? Here. So I'm taking the element in the array that's at the beginning. I'm taking it out. That's what shift is in JavaScript. I was using unshift here, so adding it from the front. So yes, you understand, it was a stack. I was using my queue as a stack. So basically, when you do that, your depth first search ends up being no, your breadth first search ends up kind of being a depth first search. So, oh, when I realized that, anyways, I'm glad I found it. Fun stuff. Okay, so if my current layer queue is empty, I don't want to break out of that while loop. I want to go to my next layer queue. You know, at this point, I've got my termination see, should not get here, right? This is where I'm breaking out of the while loop and the function at the same time. So I could do the very wise thing and basically do this. Yeah. Yeah. And then, oops, not what I wanted to do. This is what I wanted to do. And just go, all right, if the current layer Q is empty, if it's empty, I want to be basically, okay, so I basically want to make the current layer Q the next layer Q. And the next layer Q to be a new array. So that's a bummer, right? Need to create a new array, but only once each layer, so that's not a big deal. Okay, cool. So that makes sense, I think. If the current layer Q is empty, make the next layer Q the current layer Q, and give us an empty next layer Q. And then just keep going with our algorithm. And keep going until we have found everything we're looking for, which, eventually I'm going to have to take the time into account. But for now, let's just do it that way, let it crash if need be, and that way we'll see how it performs. um, other than that, what do I need to change? Oh, well, obviously, I haven't changed much here. The behavior is exactly the same. It's just that I'm doing it over 2 queues. Do you accept tips help before I leave, or you want to find by yourself? Yeah, man, of course. I am open to any tips or help or comments or whatever. If you feel that you can save me some time at this point, I'll take it. I'm all ears. Or eyes, I guess, since I'm reading your chat. If you look at top players' game, they learn for 5-6 turns. This will get you to silver easy. Oh yeah, right. I can basically just cut off the depth. That's an easy way to do it. The 5-6 first one's hard-coded. Hard-coded, what do you mean by hard-coded? If turn 6, learn 0. If we're under turn 6, learn. Oh, learn 0. Are you saying that for the 5 or 6 first turn, they always just learn the one that's the free spell? Is that what you mean? Yeah, okay, cool. So for the first 5 or 6 turn, they just learn. They don't do anything else but learn. Yeah. I'm not there yet though. Like I'm not taking learning into account yet. But yeah, that's something I'm going to look into once I can just figure my search. You have better mid game, end game. Okay, what about your scoring function? I don't know if you were around when I was explaining it. My scoring function is basically to guide the search, right? That's if that's what you mean. Um, I'm just basically using something simple where I look at my inventory, look at the target's delta, and look at the difference and apply for tier 0, multiply it by 1, tier 1 by 2, 3, 4, which is not perfect, but should be fast to compute and should be enough to guide the search a little bit. Potion price times 0.9. To depth, really? That's like super cheap to implement, but sooner the potion comes, the better score. Yes. Huh. Okay, and the depth in that formula is the depth I'm currently at in the search. And what's the I'm trying to understand. Let me save that. That's really interesting. How'd you come up with that? Like I'm trying to understand what's behind it. Are you using a Monte Carlo tree search algorithm? Because that's what I was going for at the beginning. Okay, just pure Monte Carlo. Wait, hold on. So you're basically making random moves. You're making simulations using random moves. And how does that work? So you're starting with a state and you're saying, all right, just random moves. And then what? Parentheses are wrong. Oh, yes. Thank you. Oh, by the way, um, this here is for power of, right? The caret here. It's not the XOR bitwise operator, I'm guessing. Okay. State while time copy, state copy, find depth, generate moves, play random. Select best one, yeah. It's interesting. I wouldn't have thought of just doing that. good to know that you can get some pretty decent results with that. Copy the state for I in depth. Generate moves. Play random. Move. Increment score. Select best one. So your scoring function, right? But how are you? Okay, so you're building a tree though. No, you're not. So you're starting at your root state. State to copy for I in depth. Generate moves. Play random move. Increment score. So that would mean that you're storing the score. Random, generate move, random move, increment score. Okay, so you're keeping. Okay, you're keeping. Right. Okay, so for each playthrough, you're obviously storing the steps along with the score once you end up finding whatever you're looking for. And then you start over from, okay. So you're probably just, okay, storing the best you've found so far, I'm guessing. Right, so it's basically a while loop. While there's enough time, start with my root state and generate a bunch of random moves until I find whatever I'm looking for. But no, the score is the score guiding your search at every step. No, it's just it's Monte Carlo, so it's just random, right? So random, 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 random. Eventually get to where I need. Evaluate the score. Save the steps with that score as the first one that I found. Loop again. Random simulation. Score. Is it better than what I had stored? Yes, great. This is my best solution so far. Here are the steps. Keep going. Random, random. Okay, 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 okay. Huh. That is very interesting. Very, very interesting. I wish I would have thought of that earlier. By the way, I think there's a problem with the chat. I don't know if you guys are trying to. I'm not seeing the. Let me see if I can. Yeah, there seems to be a little problem with my chat application. Just give me a second to see if I can fix that. You guys might have been saying stuff in the chat and I was missing everything. Chat, okay, careful. We're wrong. That's where we were at. Not even tree search. Move increment score. Sorry. If it's a brew. Which, when play. If it's a brew, I do score plus potion price. Uh-huh. That's what you were talking about. In the game object. In this case, the copy store only the first one move. Uh-huh. Ah, okay. Okay. Right. I think I get it. All right. I think I changed. Fixed my chat application here. Sorry, guys, if I wasn't very responsive for the last few minutes. Okay, so you're storing the score along, right. You only need the first step, I guess. Hmm. You're incrementing the. Okay, so okay. Sorry, yeah. Let me show you. I was just thinking aloud with um, what's your name again? Minecraft Atomos. Um, yeah. So okay. So basically, you try for each possible first move from the state you're in. Just you just try a bunch of random simulation, store a score for each of those possible moves. Okay, I like it. I like it. It has the merit of being relatively simple, again, because it's Monte Carlo tree search. Just plug in the rules, do your thing, get a result back. Oh, that is so interesting. Why I didn't think of doing it that way. That's a great idea. And how would that differ? How would that differ from using a Monte Carlo tree search? There's no backtracking. Sibo Omega. Yeah, that's the thing. I'm curious how many plays I could reach with JavaScript, like probably orders of magnitude less, right? And that's where the problem is with Monte Carlo, is you need a big enough sample for the result to be close to the actual thing. And with my MCTS, I was nowhere near that. So, and that's what I've got in the arena right now. So it's just barely better than random. But it was enough to get me to the middle of the pack bronze, I guess. Um, hmm. I'm curious. Yeah. See, this is what happens. This is what happens, right? Like I'm tempted now because I just love Monte Carlo stuff. I just love the idea of letting the machine do the work, right? Just like simulate a bunch of time and a StarCraft challenge, 30K sim in JS, 4 million in C++. Oh my god, yeah, it's not even worth trying. That's the thing. I shouldn't even try for those if I'm gonna do it in JavaScript. Um, yeah, that's true. I did learn a bunch by doing it. Yeah, just because it's fun. That's definitely true. That's definitely true. TypeScript is, you know, what I use most at work. I'm very comfortable with C# as well. So I could do C#. That would probably be a lot more performant than JavaScript as well. But I'm thinking maybe I should just skip to Rust. I have played with Rust a little bit, kind of like it. Great compiler. We'll see. We'll see. All right, so for now, I think that thanks for the tip, eh? It's at least it opened my mind to other options. I think, given the fact that I don't have much time left, I think I'm going to stick with the beam search, if only just to implement it. It's the first time I try it. I have been reading and hearing about it for a few months now, and I figure why not? Let's try it. Let us try it. Coding is a bit intimidating for me, but also seems really rewarding when it works. Yeah. Yes. For sure. Both of those are true. As you gain experience, it won't be as intimidating as it might be now, but it'll keep being rewarding. So keep pushing. All right, I got a code. I got a code. So, okay, we've got both of our queues. And I am switching between them. Now, I actually have 2 tabs on it open right now, but I couldn't find proper tutorials, just games where you expected to already know the answer. On CodinGame you're talking about, right? No, games where you're expected to already know the answer. Yeah, look for I think, like classic easy puzzles. They're relatively simple to get your feet wet, and I don't think they expect you to know the answer. It'll be a challenge, but all right. So I guess we won't be getting here now, since we've got our okay. So we've got both of our queues. We're switching between the queues at each layer, so that's good. Now what I need is the beam part of the beam search. Reduce that. And when do I do that? When do I do that? When do I do that and how? I guess it would make sense to prune the layer when I'm about to start iterating through it. So right in here somewhere, I should say, okay, so if current layer queue, okay, I'm done with the current layer. Let's move on to the next layer, but I don't want to do the entire thing. I just want to do a subset of that. So I guess this would be the time to sort the layer according to my heuristic and then prune it and then make that the current layer. Yes, I think. All right. Okay. So if we're done with the current layer, cool. Let's take a look at the next layer and sort it. Sort it how? A and B and like that. Which which do you prefer out of these two, Python or C++? If you're asking me, I would probably say Python because I have very little experience with C++. I don't have much more in Python either, but Python is, a higher level language. It's got a garbage collector, don't need to worry about the memory. Um, so, if I was in a bind and I was like, you got to code this and your only choices are Python or C++, go. I'd reach for Python. Um, Not that I think that it's better than C++ or the other way around. It's just at this moment, I probably have, I don't know, 10 hours of experience in both of those. So if I needed to do something quick, yeah, I'd use Python. Most companies are using Python, but my course is in January is a C++ course. Where did you learn to code? Okay, so um, most companies are not using Python and they're not using C++. Most companies are using JavaScript. That if you don't care about what you work in and your language and the kind of, if all you care about is getting a job in the tech industry as programming, um, that's subjective, right? But what I'm seeing, JavaScript, TypeScript, JavaScript. Everything now is web-based. Almost everything, right? Most everything. Let's be fair. Most everything, and it's moving towards that even more, right? Less and less native applications, more and more web-based applications. PWAs, progressive web apps, are around the corner. So, yeah, if you care about getting a job, JavaScript is a good place to start. It works everywhere. There's Node.js on the back end. There's embedded systems are using JavaScript, IoT. It's if you learn JavaScript, you can do anything. If you learn C++, you can build the next Windows or a super complex video game engine, which is super cool. But there's only a small subset of the tech industry that needs those skills, right? There's definitely a lot of work. I don't think you'll have a hard time finding work if you're really skilled at those, but yeah, it's just Python is getting up there though. It's mostly used for data science, machine learning, and there's more and more of that. It's really hot. Like there's a lot of buzz surrounding it right now, but I guarantee there's probably orders of magnitudes more companies hiring JavaScript devs than Python devs. Yeah, and take my opinion with a huge grain of salt, right? Somebody could come along and say that I'm completely wrong and it's the opposite and Fortran's the future. But you know, if you're more interested about more back-end stuff and it just grosses you out to spend time in JavaScript, um, then I'd say if you care about employment, um, Java and C Sharp are probably your best bets. A lot of business applications being written using those two languages. If you end up with C++, Rust, they're super cool languages and they're really good at some of the things that they do. Even Go. Um, there's just less opportunities out there. Might grow in the future. I don't know, especially for Go and Rust, maybe. C++, I don't know that it's growing that well. It's growing probably because everything's growing, right? Programming is growing, like everything's software now. So really, I guess my I guess when all is said and done, just pick something you like that's not completely antiquated, and you'll probably just be fine if you're skilled at it. C++ and JS quite close in syntax. Yes-ish. I would agree with that. C++ is also really used for really big compute. Yes, definitely. Example, my company backends are in C++ because we have millions of requests per minute. Sure, that makes sense. It does make sense. Computer programming and analysis, I think that once I get my foot in the door with a good understanding of one type of coding, I can use that to help. The great thing is, if you learn C++ in school, it's definitely not the easiest language to start with, I would think, but you get really good fundamentals. Like when you start with a higher level language that has a garbage collector, the whole memory aspect of software and even like the hardware implications, you kind of skip that, right? There's a nice abstractions that are done for you, which is great, really. Makes your job easier. You get to produce software that's easy to maintain, easier to read the code, and you get to move faster. But you will no doubt hit some um, snags once in a while in your career or in developing stuff where you're like, this language is not cutting it right now for performance reasons, and I don't understand why. I don't know what the machine's doing, what's going on behind the JavaScript part of things. How is it being compiled and all that stuff. So if you start with C++, you'll get a much better understanding of the deeper things related to computer science. See, so many people never saw a low-level language and they have no idea is happening because of this abstraction layer and turn into shitty code. And when you don't do it later, it's important to master higher level language and produce quality code. Yeah, for sure. Yep. That is, I would agree with that. I would agree with that. So it's really, it's kind of a hard choice. I ended up, the first language I ended up learning was C sharp. And I quickly switched to JavaScript really because it was easier and there was a lot more tutorial. That's another factor too. Depending on how you're learning, I didn't learn in school. I learned by myself. Didn't do a boot camp, didn't nothing. Just taught myself with books and tutorials and blog articles and online courses and there is a lot more material for learning JavaScript and understanding JavaScript than there is for C++ or even C Sharp or even Java or I'd even say Python. So that's another factor that you need to consider. I got a code, man. You guys keep chatting. All right, so I'm sorting my next layer queue. I want to sort it. So how do I sort it? I sort it um, by using my heuristic. Hey, token hemp shire. Thanks for the follow. Wishing you the best with your budding career in software development. Hey, no problem. No worries. Um, next layer queue sort. Yes. Okay. So A, that is my node. My node has data. Data is, what do I need for my heuristic? I'm doing too much talking, not enough coding. Context switching is killing me. I need the inventory and the targets. Oh, right. My current inventory and the targets. Cool. So data, I do have that, right? Inventory, yes. And the targets is available in the higher scope. So I could do heuristic. Heuristic. Thank you. Pass in the inventory, pass in targets. Cool. And we've got our score. Now, I need to, okay, this is where I always forget, man. Here's here's a page I visit probably like once every 2 weeks, if not more often than that. MDN Ray.sort. Cause the order, man, it I always forget, right? So if you want it to be sorted, I want it to be sorted. Let's see, higher is better in my case, right? So I want the highest one to be at the beginning and the lowest one at the end. And as we can see out of the box, if you don't pass in any parameters and you're using numbers, it'll sort it the other way around. So I want the opposite. Let's try it here. A, B. If I do, I think B minus A is what I'm looking for. Missing, right? Eh? What? What am I missing? I am missing that. Yes. We'll get it. Here we go. Okay, that worked. Yeah, that's exactly what I was looking for. Okay, so B minus A is what I need to do. Okay, okay. So that's, okay, so there you go. I wasn't doing it right. So heuristic. B dot data dot inventory targets minus heuristic. Now, hold on. Am I going to screw that up because they're negative numbers? Maybe? Let's find out. No, okay, still good. That's still what we want. Cool. I need to return that. Great. Now, one thing that's kind of bugging me is that I have a feeling, like, imagine that I have thousands of nodes in the layer. Sorting that won't be trivial, will it? In terms of compute time, I guess we'll find out. So, okay, now we're sorting it. Cool, it is sorted. Now what? Now what? I still don't have a beam search. I still have technically breadth first search, except that I'm prioritizing looking for better. Right. So it'll be I'll find an answer probably a little quicker because everything on each layer will be on the left, but I want to actually not look at the entire layer if I don't have to. So I need to somehow just cut off a part of it. Now the question is, how much of it do I want to cut off? How much should I? That'll be fun to play with. Okay, so let's do that. How about we just keep a slice of the best 10 nodes and see what that gives us. So that means that for the first few layers, probably the first 3 3 layers. I'm doing the whole thing. But after that, the beam will kick in. Can I just, do I need an if statement for that? Next layer. Actually, I can do, let's do that after. That doesn't make a difference if I can do that here. Okay, so we'll do it on the next layer. So next layer q dot splice, oh, in place is slow, but slice, slice creates a new array. I don't know which one is faster. I guess splice would be slow if I was splicing in the middle, but I hope that the fine folks at V8 have optimized it so that when it sees that you're just basically slicing off the end of the array, you would think that's optimized. That's got to be optimized. That's got to be faster than slice, which returns the section of an array as a new array. We'll see. That's the thing with JavaScript. It's hard to know how different things are optimized or not. For instance, I wasted a bunch of time because I turned some of my stuff into bit arrays, numbers in JavaScript, right? Using binary. And I wanted to store some data in 49 bits. JavaScript only has a bitwise operation on 32-bit ints, although it's stored inside a 64-bit float, but whatever. So I figured I could use the new big int that they came out with not too long ago. That's, infinite size, and it supports your usual, mathematic operators, arithmetic operators, and bitwise operators, and I thought, well, if I only have 49 bits, surely the engine will optimize, right? It's written C++, V8 is in C++. Surely it will optimize and store it as a 64-bit int, store it in register, and then it will be fast. No, I ended up finding it was horribly slow, because I read up on it afterwards. I should have done that before, but I read up on it, and right now it's relatively new. They don't know how folks are going to use it. So they're storing your bigints as an object in memory on the heap. you know. So that's a bunch of stuff I did that I had to undo. All right, so we're splicing. We're splicing at index. What did we say? 10? Is that inclusive, or I can't remember. Removes elements from an array and, if necessary, inserts new elements in their place, returning deleted elements. Start number, it doesn't say, but yeah, 0-based allocation in the array from which to start removing elements. Doesn't say, but I'm pretty sure it's inclusive, right? Usually is. Delete count, the number of elements to remove. I'm pretty sure I can leave that off and it'll splice the rest of it. Let's find out. The end array splice. Index at which to start changing the array. If greater than the length, it won't be. If negative, oh, it might be, right? If we have less. If greater than the length of the array, start will be set to the length of the array. In this case, no element will be deleted. That is exactly what we want. But the method will behave as an adding function, adding as many elements as items provided. Nope. Nope, nope, nope. Delete count, optional. Integer, indicating the number of elements to the right to remove from start. If delete count is omitted, or if its value is equal or to a larger than all the amounts from start to the end of the array. Great. That is exactly what we want. It'll be simple. I can just leave it like that. And I don't even need an if statement or anything. If it has more than 10, it'll splice whatever's after that. If it doesn't, it won't do anything. Okay, so that'll need to change later once if I implement some sort of backtracking, because instead of just throwing away those nodes, I'll have to store them somewhere. But let's not worry about that for now. Let's just see how far we can get with this. And with that, I think we actually have a beam search now, right? I'm done with the current queue. Cool, let's look at what's in the next queue. Right, let's sort it from left to right. The best one, the highest one being on the left. Let's get rid of everything that's more than index 10, 10 and more. So basically, just keep the first 10 elements. Make that new sorted and pruned layer the current layer. Get us a new... Oh, I just thought of something. Yeah, okay, that's good. Get us a new layer. Increment node count. Yes, good. And then the rest should stay the same. All right. Dare we try this thing? Okay, what's going on here? Oh, I just had something running in the other. Cool. Don't need you. Let's build. How exciting! All right, we are built, which will update our code automatically. And here we go. Please don't blow up. Please don't blow up. Please don't blow up. Please don't blow up. Well, we got to 31 turns before something went horribly wrong. And we timed out, I'm guessing. Has not provided one line in time. So I guess that's a timeout. And oh yeah, basically the same thing happening. Did I create my own assets? For what exactly? Like my house? Someone else built it. I didn't create it. What kind of assets are you talking about? Yeah, timeout can be code too slow or no output because of a sneaky condition. I have a feeling it's slow, but try to put a default action such as wait. Yes, that would fix the problem. It won't help me pinpoint it though. I'm wondering though. Okay, let's just take a look a little bit here. 6 turns down, count 139. That's the first turn. And then it found it. You will know if it's too slow or not. Oh, right. In the sense that if I do output something, then for the game, did you create the characters? Look like no, that's I didn't. Token Empire. I didn't make this game. This is CodinGame. They made the game. I just make a bot to play that game. Yeah, I think that it's inspired by Zelda. No worries. uh, I do not have the art talent necessary to do that. Not much of a drawer. There is the Triforce on the table. So, order 66. 4 turns, 3 turns, 2 turns, 1 turn. Boom. So we're good. And then 8 turns. 454 is the count. And we're doing just fine at 454. Another one. Then 4,000, and we're still cool. Went down 11 turns. 9, 8, 7, 6, 5, 4, 3, 21. Oh, that's interesting. Just went up. Boom. Because what? Oh, I had to switch because he brewed what I was trying to brew. Uh, I'm going for 52, which is this one. Yeah. And so we change tack and we find something else. We've got a lot of stuff in our inventory, so we quickly find something else that's interesting. Go boom. And this is where we time out. Okay, so I'll do what you suggest. I will put a well, I guess I need to implement the time thing now if I want to do that. Okay, let's do that. So, time. Pass in the time. Thank you. So while do I want to update it? Yeah, let's do that. Well, if I do it, yeah, let's do that. While time is greater than 0. So let's call it remaining time, just to be remaining time. Cool. Now we need to update that. Let's see. This shouldn't be taking too much time here. What am I doing? I'm just creating 2 arrays. And your root node, yeah, that should be pretty much inconsequential. Start the timer. Yeah, I didn't have it. I didn't have the time stuff, but it's okay though. I was planning to put it in, so might as well do it now. Start the timer after the first input. That's already done. I already, yeah, like in my main, I already have that set up. As you can see, maybe not. What? Oh, here. Good. Boom. Okay. So for the first turn, I'm starting the timer after the... Where am I starting it? I don't know. At the very top, I guess. Which I don't know if that's the right thing to do. Maybe it should always start after the first input. Yeah. I've got that going here. I set how much time I want to give it, and then I can just pass that in to my bot here. Did I get to silver? Not yet. I would have to actually submit my code at some point. I haven't done that in like 4 days, I think. Oh, we're getting close. I got a few things I need to fiddle with, and I'm pretty sure I can make it before the end of the contest. Will I be able to get to gold? Hey, no problem, man. Don't worry about your English. As long as we can understand each other. I'm sorry about my English, too. So, remaining time, just need to update that in the loop here. Um, at the beginning, at the end, of course. At the end. So we need to do time remaining, not remaining time equals now, convenient little function that I made for myself that works both in the node environment or in the browser. So now, nope, yes, nope, what? Oh, what am I missing here? I'm missing something. I'm missing something. I need I need a start time, really, don't I? Which I'll put here, I guess. All right, so I'm starting here. Cool. So remaining time, start time. Yes, okay. So now I can just do remaining time is equal to now minus start time. So that's the total time I've taken so far. That's not a function. So that would give me the total time I've taken so far. But the remaining time, so I need to take remaining time. I need to reduce remaining time from that, right? So, oops. Remaining time, okay. Remaining time minus elapsed time. Does that make sense? No, it doesn't. It does not, because if I'm updating remaining time every time, why? What am I doing wrong here? This isn't usually so difficult. So I've got a budget, which I call remaining time. Cool. So I start. Great. And then maybe I should have the start time inside this here. Oh, that would make more sense. Instead of having this not updated, I think that's where I went wrong. So let's do that. All right, man. Have fun, Vladinson. All right, so start time is now. And okay, so this will be how much time this particular iteration will have taken. remove that from remaining time. That makes sense. Yes. That makes sense, right? So let's say we're starting with 15 milliseconds. Cool. So 15 milliseconds. It took us 2 milliseconds to do this turn. So now remaining time is 48. And do another one. Start the timer there. Now. Yes. Okay. So this works. This works, and we're going as long as remaining time is over 0. And we pass in our budget here, which I've got set for 35 milliseconds right now. Now, once I'm done with that, I will have some actions. I'll probably, like, I doubt I will never have found not even a single action. All right, let's just do that. And, okay. Seems to be a problem here in my bot code. What did I change? I changed that I didn't forward the time. Time, yeah. Number. Put that in here. Time. Okay. Let's go on with targets now. Did I change that? Oh, we're back to undefined now. Yeah, I need to have my trusty. Well, actually, I could probably, if we run out of time, return whatever results you have, I guess. Right, yeah. Yep. Where am I? There we go. Return results. Okay. And then if I don't have anything in there, if I don't have anything in there, if so, return selected 0. Let's log, should we? If you have nothing, learn the first spell. Oh, that's a pretty good idea. Instead of resting, I was going to say just rest, but it's a free. I guess, yeah, that's smart because resting is. I guess it's a toss-up between resting or learning, right? It would make sense to rest if. No, I like it. I like your idea. Let's go with learning. I haven't implemented learning though at all yet. Like it doesn't even exist anywhere in my code. Yes, that's a very good idea. But for now, you know what? I just want to run it first, see what happens. Oh, what happened there? Desynchronized or something. Interesting. But I've got a problem in main because I'm not passing in the time. Yes. Turn. There we go. Now, I don't know if this is wrong. Come to think it might be. I start my timer for the first turn. I start my timer before the input. That wrong, you think? Does it really only start when I get my first input, the timer? I think it might, eh? Yeah, I know I have 1 second. What I'm saying is, where should I start counting the time? Is it always after the first input, including even on your first turn? Or should it be like at the very top of the... Actually, no, does that mean that anything I do before reading the first input comes for free? So I could like have like some complex, I could be building, like, of course I didn't get any input, but I could, I don't know, like if I decided to run something for 3 seconds that builds a graph out of thin air with whatever I decide to give it, I could do it and I wouldn't time out? I doubt that. Yeah, I've read about that. How does that work again? It's like you basically put code after your output and before the next input. That'd be too easy though. Creating a thread. I thought you couldn't create threads on the platform, on the CodinGame platform. I certainly couldn't do it with a... You can't. I like it. Do explain. I am intrigued. I am a moderator, so I shouldn't. Okay, yeah. Let's not give some. Let's not give bad ideas to everyone. But stuff exists on the web. I will have to look it up. But obviously, JavaScript is not the language to do that. Although, believe Node now has actual threads. Yep. Node now has worker threads. I haven't played with them all that much. It used to be that if you wanted to do parallel programming with Node, you needed to use another process, right? And then the processes would talk to each other. But now I think you can actually use threads. So Node 12.13, I don't know when it was introduced. I am looking at version 15, but don't know when they were introduced. Threads. It seems to be about a year old, so I don't know what version that would bring us to. This one's talking about version 10, so they might be they might be available on 12.13. But again, I doubt that it's worth it in JavaScript. What? How'd that happen? What? Wait, am I logged in with somebody else's account? What the heck? I didn't push. I was ranked like 1,000 something in bronze. How did that happen? That's weird. Let's refresh this. No, it still shows me as bronze. So this is a glitch or something. Unless this isn't updated. Oh, it's on Code of Ice. Oh, you're right. I didn't see that. Oh, cool. Yeah, I had done some stuff with it. Um, I don't know, like a month or two ago. Interesting. Okay, so something to read up on, I guess, for fun. How to do multi-threading in, if there is a way to do it, and I managed to do it with Node, this could give me, this could help, right? But somehow there's a cost to multi-threading too as well, so I don't know if it's going to end up being good in the end. So what was I trying to do here? Oh yeah, pass in. I did that. Let's rebuild. Cool. Now let's just set that up again. Huh, completely lost it. That's weird. Upload from local file. And we're in business. Well, that's not good. Cannot read property 0 of undefined right off the bat. All I did was implement the timer. I guess it's not finding anything in time. Line 185. Will brew something action get yeah. So selected has nothing. It's empty. Wow. So I'm timing out. No, that doesn't make any sense at all. Something's wrong. Time, passing the time. I've got my time here. Start a timer, remaining times bigger than 0. At the end of the loop, remaining time equals remaining time minus whatever time was elapsed. That seems sound to me. Let's try another run, see if the exact same thing happens, which I'm sure it will, yes. The heck. So I'm bugging out. Obviously, I'm bugging out of the search without having found anything. On the first turn too, which doesn't make sense at all because I've got like tons of time. I would expect it to, let's see. Remaining time minus elapsed time gives us the new remaining time. Yeah, that just seems right. All right, well, let's just console log some stuff. All right, so we start with actually let's put it in here. Right. See how many loops we get, if we even get one, or if it just remaining time is bigger than 0. Yeah, that should work. Now watch it time out because too many logs to the ha. Ha. Okay. 1. My remaining time is 1 at the very beginning. What the heck am I passing in there? Time. Main. I'm passing turn instead of time. Man. Time. So, right at the very beginning of the game, I pass in 1. So you've got 1 millisecond to go. That's, so, okay. That, I guess we found the problem here. Can get rid of that. Otherwise we'll get like 1,000,000 logs. Rebuild. And play. Oh, no, not play here. Yeah. Ooh, we get to 64 turns. I think we get to play the game. And we're off. So just quickly, I want to see if there's anything weird going on where I'm like wasting time, not doing something that works, or yeah, everything seems fine. Oh, wow. Look at how I get my ass kicked. That's the boss, right? So, boom, I brew this, take the lead, then I get the none. Okay, he really starts to. Oh, okay. I mean, I'm doing stuff. I'm doing stuff. Of course, I'm not learning or anything like that, but I know that there's a bunch of people ahead of me in bronze that are not even taking all the bronze rules into account. So what I'm trying to do is beat them, and once I'm satisfied that I can't go any higher without taking into account those new rules, I'll start taking them into account. But I wanna tweak my search algorithm to be as efficient as it can with the current rules. So I'll brew order 51 in 9 turns, so that'll be interesting to see, right? Like just by looking quickly, did we find the best option? Uh, like the quickest path. Could we do this in less than 9 turns? Let's think about this. We already have that, so that's good. Actually, let's step through it, see how he does it. 9 turns, 8 turns, 7 turns, 6 turns, 5 turns, 4 turns, 3 turns, 2 turns, 1 turn. Cool. Let's just rewind. Okay, so we start off by converting that to that. Okay. And that, yeah, makes sense. and then we rest. Okay. Did that make sense at that point? I might have gone for creating another tier 0. That might have been better. I don't know. All right, he's going for another one of those. Cool, resting again. Creating that. I guess in the end doesn't really make sense whether you do it at the end, if you rest at the end of those or at the, and now we're good. So that took us around 9 turn. Pretty confident that we did find the best way to do this. Now we're going for, we're brewing, okay. Okay, so this is interesting, 17 turns. I went to, oh, that's, look at that. I went 17 deep, but only 130 node counts. So that's your beam search at work right there. Because 17 deep with the breadth first search would have been thousands of nodes. So that's pretty cool. Now the question is, was that the best path that was found for this? I wonder. And what's more, the algorithm finds all of them. It only stops if it finds all of them, or if it runs out of time, which I don't know. I don't know at this point if that's what happened. Presumably it did not. I don't know. I'll have to log and see. Cool. So that's pretty good. Oh, would you look at the time? Guys, I'm gonna have to go eat lunch. But we're making progress. My hope is that you'll see me higher in the Bronze League today and possibly into the Silver League tomorrow. We'll see. Thanks for watching. Thanks for spending some time with me and chatting. This was fun. And this is probably my last stream for this challenge. I don't know. Maybe over the weekend, we'll see. But maybe not. So this was fun. All right, guys. Bye.